Bring this up. Perfect. All right. Number one. So here, the first one, as I said before, you will be plugging in this function. You'll have this function t minus 49 over the square root of t minus 7. And the question is, let's put some values in and see what this approaches. Again, this just means we're going to use a calculator. And so one of the things we're testing here is your ability to not just do stuff by hand, but to be able to use the technology to get you where you need to go. And so our technology of choice is the future calculator of choice, and that is Desmos. Right now, again, the TI world has control over the market, but that will soon be changing. G of X equal to, now when you use Desmos, you'll need to, they prefer the letter X, and so you'll just have to use that one instead of T. And then you'll do square root of X minus 7. See that that matches up. It does. And then you can just create a table. Hit here, create a table, and then put in these values. And then that's game over, right? So they want you to put in from the left and then from the right a 49. So 48.8, 48.9, 48.99. You just go here, 48, 48, 48.9. I'm sorry, not there. That's X. Trying to go to 49, so close. I was tripping. Let's put that in there. Click there, right? 48.9. There you go. And then you just need to round to however they want you to round. 48.99 and so forth. Floor is open for questions about that. 49.1. You just put in the ones they need. And round correctly. All calculator Desmos. Let me go back here and just copy this over for the notes. So just straight up put that in there. Okay. All right, so then it looks like the answer is getting close to 14. And so then you would say, oh, then it looks like the limit is actually equal to 14. And then we're good. Questions there. Right. Again, if you want to practice these for the final, you, in addition to the practice exam, you can go in the study plan and you can do chapter 2, section 2, problem number 9. It will give you a bunch of these to do. Limits, we'll zoom in a little bit. As Angel had already attested to, this thing is well within our range to crush. So my people who are rolling at a C right now, if you crush this thing, you might just get there to an A. So let's make this happen. G of 1 is the black dot at 1. G of 1 is 4. You're just going to read this off. And we're talking about doing this like we mean it, like seriously focused, right? From the left of 1, you're on this thing, it goes up to 1. From the right of 1, that means you're on this part, 4. You just burn through these. Because the limit from the left is 1 and the limit from the right is 4, and those two things are not the same. This means that there is no limit, and as you might expect, we're going to put does not exist because this is not equal to this. The black dot at 3 is straight up 1. As you come from the left of 3, that throws me up here to this thing. That limit is 4. From the right of 3 has me on this thing. That goes down to 1. The value at 4 is 2. The The limit as x goes to 4 from the left and from the right is also 2. Right? So calmly, slowly, your test is untimed. So calmly, slowly, just going through that very carefully. These first two should be ones that are very much within our reach. As you may know, as you prepare for this with the practice exams, you know how I roll, the order's the same. You are going to go methodically through and find out wherever you might be struggling the most, and you're going to take care of it. All right, so we've answered all of those. Sketch a graph of a function f with the following properties. We'll make these notes here. Remember that f prime positive means f is increasing. F prime negative means, let's put f here, f is decreasing. F double prime positive means concave up. F double prime negative means concave down. Right, so here we know how multiple choice works. This is going to be process of elimination. Let's just be clear here that let's get this diagram that we had earlier, that when we had a little circle like this, let's use a different color. When we had this, this, right? Then this is f prime positive, f double prime negative, f prime negative, f double prime positive, f prime negative, f double prime is also negative. This thing's increasing here, and it is concave up. All right, so we'll just hit the branches and we'll start to eliminate. This thing needs to be increasing and concave up, so it better look like this to start. Increasing, concave up. It better be increasing to start. Increasing to start, not that one. Okay, so between, well, let's just go ahead and, I think we got it right now. It needs to be concave up before -3, and this is not concave up. Game. Right? And so again, you can check everything else. You know, the next one you might want to check, if you needed to, would be this one. What does it do at the end? Right? It needs to be decreasing and concave down, and this one's also doing that. So you probably, in doing this, only need to check the beginning and the end, and that will probably get you all the ones that you need. Number 4, they give you this table. They want to know h prime of 3. H of x is equal to f of g of x. By the chain rule, h prime of x is equal to f prime of g of x times the derivative of the inside, which is g prime of x. They want to know h prime of 3, which is equal to f prime of g of 3 times g prime of 3, and you best believe all of this information is in the table. This is equal to f prime of g of 3, the value of g at 3 is 4, times g prime of 3, which we can call out right now. G prime of 3 is 1/9. The remaining thing is, what's f prime of 4? The value of the derivative of f at 4 is -5. -5 times 1/9, -5/9. Somebody in my family is unmuted. P prime of 2, well, P of x is equal to G of f of x. P prime of x is then G prime of f of x times f prime of x. We're digging this at 2. P prime of 2 is G prime of f of 2 times f prime of 2. This is G prime of f of 2. Value of f at 2 is 3. times f prime of 2, the derivative at 2, negative 1. G prime of 3, the derivative at 3, 1/9 times negative 1, negative 1 over 9. The floor is open for questions. Straight up, finding the integral. By the fundamental theorem of calculus, I'll hold the 23. The antiderivative of cosine, the negative antiderivative of sine is negative cosine. Evaluate it from 0 to pi over 2. We'll plug in the pi over 2, we'll plug in the 0, and we'll subtract. This is equal to 23 times negative cosine of pi over 2 minus negative cosine of 0. This is 23 times the cosine of pi over 2 is 0. The cosine of 0 is 1 plus 1, 23. Just being. I'll evaluate the following integral using the fundamental theorem of calculus. Sketch the graph of the integrand and shade the region whose net area you found. Antiderivative is 1/3 x to the third minus 3/2 x to the second minus 4x. Evaluated from negative 1 to 4. Straight up tedious, family. It's true. Got to do it once though. We'll plug in 4, plug in negative 1, and subtract 1/3 times 4 cubed minus 3/2 times 4 squared minus 4 times 4. And again, Desmos will do all of this. Minus 1/3 times negative 1 to the third minus 3/2 times negative 1 squared minus 4 times negative 1. Right? Whatever that number is. Right? So you can again put this function into Desmos and then it will evaluate it for you. So then combine this. And then you're asking, well, what graph is that? And so you can either graph it yourself, or you can realize that this is x minus 4 times x plus 1. So the zeros are at 4 and negative 1. And that is looking a lot like B. Because it hits the x-axis at negative 1 and 4. Straight up quotient rule. Just making sure we've got everything down. Some rules that we need to remember. The derivative of u over v is v times u prime minus u times v prime all over v squared. It's been a while since I've said that, right? U in this case is the numerator. V is the denominator. I'm trying to make these derivatives pretty nice. The derivative of x minus 2 is 1. The derivative of 5x minus 4 is 5. Now it's all about how much MyMathLab wants us to simplify. 5x minus 4 times 1 minus x minus 2 times 5. I don't think we should take any chances. And just go ahead and write out the numerator in simplified form. 5x minus 4 minus 5 times x minus 2 all over, this is squared. 5x minus 4 squared. 5x minus 4 minus 5x plus 10 all over 5x minus 4 squared. We're talking about, that's plus. We're talking about 6 over 5x minus 4 squared. You can practice these. ID 3.4. chain rule. You're going to have your table sitting next to you somewhere of derivatives. The derivative of tangent is secant squared u times u prime. The derivative of tangent of 2x cubed is secant squared of 2x cubed times the derivative of 2x cubed, which is 6x squared. Make sure you practice how to put that in before you take the real thing. The derivative of x squared plus 6x plus 8 to the 8th is going to be 8 times x squared plus 6x plus 5 to the 7th times the derivative of x squared plus 6x plus 5, which is 2x plus 6. Got to make sure you know your trig derivatives as well. So we hit a couple of those. The derivative of sine of 10t minus 13 cosine of 10t minus 13 times the derivative of 10t minus 13, which is 10. Uh-oh, I feel like some of y'all are ready to take this thing now. The derivative of the cosine of 6x to the 5th plus 6x plus 4 is negative sine of 6x to the 5th plus 6x plus 4 times the derivative of that, which is 30x to the 4th plus 6. All right, so using the chain rule or trig functions. Implicit differentiation made this one nice for us. Right, so we'll take a derivative on both sides. Now, what makes this, what we have to do differently, because this is implicit differentiation, is then when we take the derivative of y to the 4th, we have to use the chain rule. I don't know why there's a comma there. That's so weird. I don't see them use commas that often. The derivative of 3,125x is 3,125, and then the derivative of y to the 4th is 4y to the 3rd times the derivative of y. And so then the derivative of y, solving for it, is 3,125 over 4y to the 3rd. Do not put the comma. Don't even try and test my math lab like that. Product rule, and also using the natural log. Got to make sure you know the derivative of the natural log. Product rule says the derivative of uv is u prime v plus v prime u. U in this case is 3x to the 4th. V in this case is the natural log, which is why I've given you this one. U prime is 12x to the 3rd by the power rule. V prime, the derivative of the natural log of x, is 1 over x. We'll use the formula. 12x to the 3rd times the natural log of x plus 1 over x times 3x to the 4th, and they'll want you to simplify that. 12x to the 3rd ln of x plus 3x to the 3rd. Here I just made these, just need to make sure that you know they exist, right? So the derivative of inverse sine is 1 over the square root of 1 minus x squared. The derivative of inverse tangent, positive 1 over 1 plus x squared. We have not done inverse secant, but it is this one. You just have that in your memory. Optimization problem, we will do here. Put it on a separate page, and that will be the game. non-negative real numbers with the sum of 30 have the largest possible product? All right, so we need two numbers, x and y. They add up to 30, and you want to make x times y as large as possible. So the first step we'll do is we'll let y be a function of x, and then we'll go ahead and we'll substitute in. I'm trying to maximize x times 30 minus x. That's the function we're trying to make as large as possible. Quadratic, 30x minus x squared. Oh my goodness. F prime of x, 30. Minus 2x. Need that to be 0 if I'm at the top. 2x is 30. X is 15. It's all in your hands. Get me in trouble, y'all. A. Love y'all. Floor is open for any questions.